There are a couple different framings about climate change. We want to maximize greenhouse gas mitigation, adapt to what can't be mitigated, to minimize suffering and enhance resilience, or the way Ron Sims put it, it's like breathing and eating. We have to both adapt and reduce emissions. It used to be seen working on adaptation was giving up, and there's clearly enough warming built into the system that we're going to need to do both. And again, hopefully we can maximize those overlaps. I've talked about it by saying, wait a minute, this isn't about the polar bears. It's about the sewers backing up in our streets, in our basements, or what I call the inconvenient sewer overflow. It's not going to be a major motion picture, but it's a way of talking about the issue of saying this is about how do the problems manifest in our communities and how might the solutions manifest. So the problem I think we're trying to address is get our heads around what is this new normal, as Greg mentioned, in terms of record extreme weather events around the country, around the world, major economic losses from Sandy, but also specifically in the transportation sector. In Colorado, with the recent flooding, the Colorado Department of Transportation estimates $500 million of losses from flooding in terms of impacts on roads. In Irene, in Vermont, in 2011, also North Dakota, Ohio, again, $200 of millions of repair. Floods aren't new, right? But we've seen more of them, and climate change, importantly, is projected to increase these impacts. So we can think about climate change focusing around water, either too little, heat, drought, fires, or too much, extreme storms, sea level rise, storm surge, riverine flooding. So what do we do? What can we do when the lights go off? I'll show that again because it's kind of cool. In Washington, when the derecho came through, knocks out power, right? That affects the metro, that affects traffic signals. When the streets flood, Sandy, Colorado recently, roads washed out. This shot that we've all probably used from PowerPoints of the transit station flooding in New Jersey. Wildfire, FTA's well-used photo of the buckled rail from heat. And I think it was just last summer at National Airport where runway asphalt softened and the airplane got stuck and delayed. But there are these direct impacts, but then there are these indirect impacts, which are interesting and complicated, that have to do with system interdependencies. So you can have something like Hurricane Katrina shutting down the port of Galveston and Houston, and then slowing down or stopping barge traffic on the Mississippi. By the way, a drought can do the same thing, lowering river levels. I'll talk about an example in Toronto with a culvert in a moment, or you can have multiple storms, where you get one storm, week one, week two, the other storm comes in when the soil is already saturated. There's some important flooding that comes from that, by the way, the climate model is not going to give you that kind of resolution. Or the multiple sort of nightmare scenario, pine beetles come in, weaken the trees, heat wave, forest fire, storm, erosion, these sort of cascading impacts that we're starting to see. So what kind of solutions do we have? I think there are a lot of different flavors: engineering, design, policy, planning, and I'm going to share some examples, not meant to be comprehensive, and I'm more familiar with road transport and urban transport, but some of them coming from other sectors. So if you're looking at a comprehensive, broad solution, the Thames Barrier in London, major investment, long-term thinking about protecting an entire city from flooding. Not making it perfectly adapted, but taking a big picture. We talked about the metro going out when the power goes off. Power line undergrounding. These images come from a task force in Washington, D.C. The electric utility Pepco has been a big champion of this. Again, keeping the power system resilient has impacts for multiple sectors. There are we need to look at transportation in every sector. Where are the resources in other sectors that may help this sector? And of course, that means there are fewer tree branches that have to be trimmed, because green infrastructure, as we'll talk about in a moment, is helpful. Some colleagues of mine in Washington, D.C. Told me about the earthquake. I think it was 1 or 2 years ago, minor earthquake, where the metro was closed. And so my colleague jumped on the Capitol bike share to get home. He would usually take the metro. Another colleague couldn't get her car out of the parking garage, so hopped on the bike. New York City bike use went up, and bike sales after Sandy, and it was the best way to get around for a while. Many would argue it's always the best way to get around New York City. Obviously, this is not a solution during the storm, but afterwards, as systems are recovering, it's important to have network redundancies and sustainable alternative modes. Washington, D.C. is considering a pilot to have some heavy-duty bikes that are ready for an evacuation event, sort of underground, downtown, that can be used, and Harry Trigoni is cooking up that idea. MTA, New York City, 2007. Big storm caused flooding. You can see on the left, I won't blind anyone here, the water coming in from the subway grates. Common sense solution? Well, a few inch elevation can prevent the water from coming in during that kind of rain event, and MTA has been investing in that. I call it a partial solution because here we're talking about inches of water. If you're talking about feet of water for something like a storm surge, in the case of Sandy, obviously you need different solutions. But this is helpful. Another really important lesson that Ernest Hellerson told me about at MTA was applied in 2011 with Irene, which did not cause major impacts in New York City. But it was the first time they preemptively shut down the entire system. And that did two things. It prepared the public and it prepared the MTA for the idea that when the next storm comes, the system may shut down and people can make alternative plans. It sounds simple, but it's really important part of the education process, and of course it meant that people weren't stranded in the system during Sandy. Evacuation from extreme weather events. This is Houston after Rita. And here's a library in Miami at Florida Institute University where building design, to be more resilient to climate impacts, could actually reduce the traffic load of people needing to get on the road to leave. So these students, they had cots and food and beer, whatever they need, to stay in the library, ride out the storm, stay off the road. How much can that happen? That needs to be studied. How much of that traffic can be reduced? But again, these cross-sector resilience measures, I think, are going to be important. Green infrastructure. I just walked here from North Station, so I saw a bunch on the way, but can have multiple benefits in terms of reducing building energy use. I heard a story in Boston about a building that put on a green roof and a local restaurant that was keeping bees. Their honey production went up. But more to the topic for transportation, can help make the pedestrian environment more comfortable, and again, can help with stormwater mitigation. I'm going to clarify. This is, again, more the inches than feet of water, but for something like combined sewer overflow, for extreme rain events, can be quite helpful and can be applied in many different ways. These next two images come from Dave McLeod in the City of Toronto Environment Department. There's a storm in 2005 that caused $650 million in damage. This particular culvert, the damage is $4 million. And here's kind of how the cascade can go. Heavy winds from a storm knock off branches, which go into the creek, which go downstream, which go into the culvert, which start to fill up the culvert, eventually blow it out. And this culvert not just had the transportation infrastructure, had power, had gas, had telecommunications infrastructure. Fortunately, no major problems there in terms of the gas infrastructure, but it sort of highlights how the systems are interdependent. And two important lessons Toronto got from this. One, a culvert is no longer engineer, design, build, and leave. Now inspection and maintenance is required. That's not such a big deal. Hire someone with a pickup truck and a flashlight, check out if the culvert needs to be cleaned out. And when culverts need to be replaced because they're destroyed or for regular maintenance, make them bigger and design them for more resilience. We've seen this in Vermont as well, post-Irene, the need to go to bigger culverts. And there's some interesting issues. These slides come from Jessica Granis at the Georgetown Climate Center. And they're doing a case study documenting what happened when Vermont asked FEMA to be reimbursed for building back slightly differently, a bigger culvert that would respond to flooding. And FEMA said no at first. And then they're going to fund one. And it's an ongoing discussion that I think is happening in multiple places where how does sort of the inertia of our existing policies and programs with evolving and dynamic issues where Vermont actually has a state law that allows for site-specific design flexibility, which you want to deal with the hydrology and the engineering required at that site. And so I think there's sort of a cultural issue of trying to mesh those. And Steve Miller, MassDOT here, is tracking those types of issues going forward. I think the Georgetown case study will be out in a few months. Cindy Burbank and Parsons Brinckerhoff also mentioned to me this Vermont Department of Transportation Rivers and Road training. Not about climate change, not necessarily about extreme weather, but saying let's design and operate with the river in mind. Let's increase our awareness of that. I think it's a commendable program.